Hi, Yi.
Hi, Patrick.
It's a long time. I haven't seen you in so long. let's get this party started. And I should bring up my screen. Let's do that. And here we go. Oh God. I'm gonna share this, but I should probably share this instead. All right. Let's this is not what I wanted to do. Presenter view. Hold on. There we go. I think we're just going to go with this right now. So welcome everyone. This is, yeah, I want to make sure everyone sees my complete screen, right? But Yi and I are going to be talking about building an open source RAG application using LlamaIndex. So yeah. Did you get any sleep, Yi?
About 4 hours last night.
4 hours, yeah. So yeah, we were talking just before this. Yi's got a 15 or 16-month-old. At that point, you're counting months, right? And there's just no sleep in your house, is there?
Absolutely.
Yeah.
But thanks for having me, Patrick. Really looking forward to this.
Absolutely. So let's do some intros here.
Okay. So I'm Yi. I'm the head of Typescript and Partnerships at LlamaIndex. Prior to LlamaIndex, I worked at Apple. We started a team called Messaging Apps. And so we actually built chatbots. So we built chatbots for WeChat, and there's this thing called Apple Business Chat. It's actually on every single iPhone. And prior to that, I actually spent some time in algorithmic trading. So at a couple of firms, Gecko and Citadel. I think, the thing for me about LLMs, right? The reason why after 7 years at Apple, I said, okay, I'm going to change is because it's like one of only 2 times in my career where everything I was working on is now obsolete. Like the chatbots that we had built, we had fairly large teams of people. We had, obviously quite talented folks in the ML space. We had, lots, years of customer chat data to go through. And it was like, if you look at it now, it looks like it was built by a 10-year-old, right? It looks like, now that you've used ChatGPT, you compare these, and not just ours, right? Like, you go on Comcast or you go on Best Buy and you talk to their chatbot. It feels like literally these things were just completely, completely almost juvenile in how much capability they have compared to ChatGPT. The only other time that's happened to me in my career was when the iPhone launched. I was at this company called Palm, and I was like,
sorry.
I was an intern. Yeah, I was an intern, and I talked to my team. I'm like, oh yeah, there's this rumor that Apple's going to come out with a phone, and they said, oh no, don't worry about it. There's a rumor every year that Apple's going to come out with a phone, and yeah, totally obsolete. So I think it's really exciting. LLMs are really exciting. I think all applications are going to use LLMs in some capacity in the next 5 years, and I'm really glad all of you are here.
Yeah, well, and yeah, it's funny. So I'm Patrick McFadin. Some of you probably already know who I am if because you're at a DataStax event. But just so if you don't, this is my quick all about me thing, and I'm a Apache Cassandra committer. I work at DataStax. Cal Poly engineer. For those out there, D went to Cal, not Cal Poly, so you didn't finish the job, man. Also just released a book earlier this year, managing cloud native data on Kubernetes. There's a section on there running AI workloads inside of Kubernetes. If you're looking for something to read, it's the end of the year. It's a great read, and so I would recommend it right away. And you can use my LinkedIn. I'd love to connect with you on LinkedIn. Funny thing between Yi and I, we've had so many intersections throughout the world. Yi was interning at a company that I was doing contract work with in the original .com boom. That's a funny story, but we won't tell it now.
Have to save it for another time.
Oh yeah, mistakes were made. But anyway, we're really happy you're here, Yi. I'm happy you're here. I don't know about Michelle who's watching us, but we're gonna have fun today. We're gonna learn a lot. And those of you that are out there, the if you want to introduce yourself in the chat, that'd be great. We're creating a network of people here, so let's do this. So let's get this party started. So we're going to start with a bit of a setup because this is a workshop. It'll be hands-on. We're going to do let's get things going. You can see my tabs here. We might have some stuff to do, so we will. But first and foremost, and this is something Yi and I talked about yesterday, let's make sure everybody is on the same page. I think this is our safe harbor statement, is we all know that you're stressed out, feeling behind, and has a boss that says we need an AI like yesterday, right? It's okay. You want to add to that?
I literally started doing this stuff this year, so I know exactly what that feels like.
That's right. That's right. We're all learning as fast as possible, and it's changing. As you'll find out in this hilarious workshop, stuff changed like yesterday, and we're trying to keep up with it. So this is a continuous effort. Don't stop learning. Don't stop asking questions. Don't stop. It'll be great. But also share, work together. We're all working on this together. So let's do this. So what we're doing today is we're going to build this. It's a chatbot application, and it really it actually is used in production at DataStax. And it has integrations with Intercom if you use that, Slack, and it also has an API base as well. So the whole idea and what we're trying to accomplish is just giving you the tools to do RAG without having to build it from scratch. But there's a lot of things that you can, and there's a lot of modifications, things like that. So we're going to walk through the steps. So first things first, we have a GitHub for you to look at. So this AI chatbot starter, if you want to take a look, go over to that repo right now. And I think we should probably put this in, Michelle, can you put that in the chat? I forgot to copy and paste it. But I'm gonna walk through these real quick, and this is just the getting started, and you can start working on that. And then Yi's gonna do a bit of a dive on what RAG is. So this is just to kind of get things going because we're doing a workshop. This is hands-on. Use your hands. And if you're on an iPhone and you're on a bus, don't worry about it. So let's switch screens here. So what I'm going to do is I'm going to switch over to, this is the repo that you should see. Now, there's a couple of things you can do. But the one that you really want to probably do now is open in Gitpod. Now, Gitpod is, if you've never used it before, it's pretty sweet because what it does is it creates a cloud IDE for you and lets you run your code inside the IDE. It's just like having it on your desktop. It's super cool. Now, if you want to clone it to a local directory and run it, with your own IDE, that's cool. But this is if you want to get things going. So I have done that. Here's my, oh boy, you know what I shouldn't have done? Started working on the version control. This is what Gitpod looks like. Now, I've done a lot of work. It gives you a terminal, and there are a few files in here that are pretty important. The one that we're going to do is there's a .env file that needs to be created by you, because if you've done anything with Gen AI, you know that you got to start collecting keys, right? Generating and collecting keys. And there are two that you need to do. First is you need to have an AstraDB API endpoint. So just to kind of give you the setup, AstraDB is going to be providing the vector store for our chatbot. And then OpenAI is going to be providing the embeddings support. So those are your two pieces here. So, and all these keys on here, as soon as this workshop is over, I'm going to go and validate all of them. So don't think you're going to go hack my system. Yeah. Yi, is that you on my, oh. Man.
It happened to me once.
Yeah. So I'm going to walk you through real quick on getting you signed in here. Now, this experience, if you have not been on Astra in any, like in the last week, things have changed. And I'm going to, thanks, Okta. We have this new vector developer experience. When you log in right now, you should click this button right now. And I'm going to do it. Enable preview. What this does is it radically changes the way the interface looks for using a vector database. And I've already created one. You can, when you go to create a database, it's very simple. You give it a name, a provider, a country. There's only US East one if you're on the free tier. And if you give us a credit card, then you can open up to the whole world. There's probably like 38 different places you could put your database. But because we're doing this here, I've already created one earlier. And as soon as you create this, you get a couple of things you're going to need for the chatbot. First is going to be the AI endpoint, and you can just click the copy right here, and then you take it over to your environment end file, and you copy that right or paste it right here. And the second thing you'll need is the token, and you can quickly generate a token, and you can copy it. And when you're done, paste it right here. Done. Now, OpenAI, like I said, you probably have done this 100 times, but if not, you can create a free account on OpenAI, get the OpenAI API keys. You can create a new key. I have this AI chatbot test. Again, I'll be invalidating that shortly. And when you create it, copy it immediately because you can never get it back after that. And when you get it, paste it here. You can put in a name for your table, which this is cool. It will create it for you in this app. So just give it a name without any, can't put any hyphens in it. I know I've got burned on that a couple of times. That's just not a legal thing. Then you put your OpenAI API key. This is your setup. So we're going to stop there and get this part done while we're talking. And then later we're going to walk through the actual running and have some fun with actually doing some chat stuff. So let's move on to the next piece here. So Yi, I'm going to let you go ahead and take it from here.
Okay. So
you
yeah,
just say
so
next.
just quick intro to RAG. We can just go to the next one. So LLMs are great at communicating and reasoning, right? What they're kind of bad at is knowing things, especially if it's things that are very recent or it's things that are private to your organization. And that's really what retrieval augmented generation of it is about. If you go to the next slide, like retrieval augmented generation, when I first heard that, it's like, it's 3 very long words. I kind of know what they mean, but I totally had no idea what they meant put together. It's really simple, actually. It's just about searching for the information that you need, giving the data to the LLM, and then getting the best response back out from the LLM. So in fact, you can even think about it like, when you're talking to somebody, right? Like when Patrick and I are having a conversation, we're each doing retrieval augmented generation. I'm giving him some context, and then because he
Are
has
you calling me a
context,
bot?
then yeah, I mean it's literally just like a conversation. And the more relevant the context is, the better the results. And that's a very, very important thing to remember when you're building a RAG system. So if we go to the next slide, I can show you some examples of RAG. So actually, I just saw Samez here. He's a college student over at Oregon State, and he built this cool thing. It's open source. Patrick, you can just click on the first link.
Oh,
there.
can I? Oh, I got to actually click on the link. Hang on. There we go.
Yeah. So, and then you can do talk with Samez.
What am I
have not
opening up
tested
here?
this, by the way. Hopefully his OpenAI key still works. And yeah, we can just do this first thing. Like, tell me about Samez's educational journey. Just let's try it.
Oh, okay. Well, we could do this.
Yeah.
Okay.
Yeah,
we're gonna
embarrass him if his key's revoked or something. But we'll see. We'll see what happens. Okay, and then just hit send. And
that's funny that this is what he's asking. Let's find all about Samez.
Yeah, exactly. Well, we'll see. Okay, it looks like there's an issue with the backend key.
I'm gonna try it again. Yeah.
No, So May, if you want to fix this in the next 2 minutes, I know you're online. So, but you can look at the code. What it does is it actually does retrieval augmented generation. It takes information from Samay and and that he's given the bot, and then it finds the most relevant pieces from that information, and then it actually goes and answers your question in a more useful manner because OpenAI does not know about this individual. Anyways, check it out. Check it. It's completely open source. You can build your own version. They've done a great job with UI. We just got to fix that OpenAI key, I think. Okay, so next slide we can go. Another type of RAG that you all might be familiar with is called search engine RAG, right? So basically, if you use Google Bard, if you use Bing, I think they're renaming it to Bing Copilot now. If you use ChatGPT with browsing, there are a couple of startups, Perplexity, Metaphor. What they do is they once again get contextual information, but here from the internet, right? So they're searching for information on the internet. They get the most relevant information, and then they give it to the model. But once again, here's the most important thing. You have to give it the right context. So I tried it, right? So ChatGPT with browsing, I think it's enabled for everybody, or you might have to pay for a pro version. But let's see what happens. And we'll go to the next slide there.
Oh
Okay,
yeah,
so
this looks familiar.
yeah. So ask the question, what 2022 movie won the Oscars, right? It's 2023 now. Obviously, ChatGPT doesn't know what movie won the Oscars at the time because it had a knowledge cutoff. So it says, okay, I'm going to search for it, right? So it says, oh, the movie Coda won Best Picture at the Oscars in 2022, which is correct. And then I said, well, is Coda what year did it come out? And it says, oh, it's released in 2021. So is it actually a 2022 movie? And then they're like, no, it's not. Right? And then I say, okay, well, then tell me what 2022 movie came out in won the Oscars. And it says, well, actually, I don't have that information, which is true. It doesn't have that information because to get that information, it would have had to retrieve, right, the search part. It would have had to retrieve the information about the 2023 Oscars, which had already happened at this time. This is not a gimmick. It actually, it could have retrieved that through browsing, but because of the way it was searching, it did not retrieve the right information, and therefore it doesn't have it. So when you build your RAG system, this is very, very important to think about. So if we go to the next slide, it's really the same principle that we talk about a lot: garbage in, garbage out, right?
Mm-hmm.
If you have to make sure that you're retrieving the right information, and we'll talk about some techniques later on about how to tune what you're retrieving. Final thing, next slide. I think there's oftentimes a large variety of different people, different skill levels. And that's totally okay. Like I said, I only started using LMs this year, right? But one thing that you can try really easily is Jerry built this cool Streamlit app. It's an agent that builds a RAG system for you, right? Should you use it in production? No, you should use what Patrick's going to show you. Can you use it to try it out and to see how RAG works? Absolutely. So yeah, I encourage you guys to try it out. Literally 2 weeks ago, and 4,000 GitHub stars. So yeah, pass it back to you, Patrick.
Yeah, that's pretty impressive. 4,000 GitHub stars. Yeah, and it's interesting. I kind of have my own thing in there about the RAG. The thing we were talking about yesterday is this. I think the interesting part of LLMs are that they are, they compress knowledge into the statistical likelihood of the next answer, right? So, like, if you ask it, what's 4 plus 4, statistically, the correct answer is 8. It's not actually doing math. And that's terrifying in some ways because you don't know what. I mean, you're basically rolling the dice, right? Might as well go to Vegas and play the tables. Yeah, that's interesting. All right, so let's get this chatbot working. And Jameson, I heard you. We're going to zoom in here. Hopefully this doesn't like zoom in everything. So we're going to see how this works. Okay, so I think it's the Command Plus. Ooh, look. All right, look at that. I got to resize everything now. Okay. If I can get a thumbs up on that, is this a good zoom in level or more? So we're going to get this working. And what that means is actually creating some vector data and then actually querying it. So there's a couple of parts here. Now, what I'm very happy is the README is very solid. The getting started portion of this, I covered this a little bit in the beginning where I'm like, go collect all your keys. The other thing, of course, is to run the pip install requirements.txt, and you'll see it install the library. So once you get into that baseline where you're like, okay, I have all the libraries installed, I have my .env file done. The next step is to work on your config file. Now, you don't need to come up with one right away. There's this example DataStax config.yaml file. And this has a pretty reasonable, it's just going through. So I'll just kind of walk through a little bit. It's using various libraries like this example response decider. These are all parts of this application. The LLM provider, OpenAI, and then it goes into more of the data. This was like Yi was talking about. Instead of letting the LLM tell us what's in the docs, so what this is supposed to do is essentially act as a document chatbot, right? And the idea is that we need data that is real and not just like compressed into an LLM somewhere. If you went to go ask an LLM about Cassandra, it might give you some good answers. But what we want is the exact answer. And this example, what it does is it goes through just some example doc pages that we have. And the doc pages are the source of truth. So essentially we're going to have this app read the docs. So this is the RTFM app. And then it will, after it reads the docs, it will use the docs to give you a correct answer when you ask a question. So again, if you use intercom on our DataStax Astra, this is actually code that's being used there now. So it's pretty cool. And so there's a few things here. Like, first of all, it's the custom rules. And this is, I'm going to go over to our config.yaml. We had fun with it yesterday. So you can copy the example into the config.yaml file, create a new one, and just use the defaults. Now, later, if you want to have fun, create your own config YAML, maybe on your own docs, and start exploring your own documentation or use it on your own site. This is an open source project. Go for it. And with the Intercom and Slack integration, it's really cool. So there's some custom rules. So if the user refers to database, they're assuming Cassandra. That's a common thing. If you ask ChatGPT about, hey, how do I create a data model for Cassandra for this use case, it might veer off and start giving you different kinds of data modeling advice that may not have anything to do with Cassandra. So we're just going to be very specific about this. And this is that prompting techniques. You're a prompt engineer after you figure this out. And like the question is not explicitly related to Cassandra DataStax or DataStax product or migrating. You always say, I'm sorry, I only answer questions related to Cassandra DataStax products. So it's giving it's the reasoning part of the LLM some sort of instructions about what to do, what if it can't find the answer, which is great because most times ChatGPT will give you a very confident incorrect answer. In this case, it'll just say, I don't know. That's what you wanted to do. You could read through the rest yourself, but this is where you put in those things, kind of create boundaries and the guardrails around what the question and answer in the chatbot's going to be. And then Yi and I were having fun yesterday, and oh, by the way, talk like a pirate. That could be your use case. I don't know, maybe. And the other thing that's really critical is this a list of the HTML pages to go through. So this is just a subset of our docs. Like for instance, the storage attached indexes, which are an indexing mechanism. Have a go do that. Okay, so that is our config YAML file. We should probably double click on this talk like a pirate real quick. That today will not work in the current code. Am I right, Yi?
That's correct, but I'm gonna have a PR to make that work with SAP. Well, I already have a PR, so
You
I
have
can
a
take a look at.
PR.
Yeah,
Yeah.
yeah.
And I think, just to keep people online, Yi will explain why in just a minute. So there you go. So you better explain why, Yi. And welcome to the world of LLMs. Okay, so what do we do once we have this config file? There are two steps that we're going to do. So I'll go back to the README. It's all in the README. So once you get everything set up with the config file, there are two steps that you need to create the embeddings. Now, when I look at my database, I need to make this work. And so when we go through the actual setup, there are two parts. There's whenever I look at my documentation, when I have this app look at the documentation, what it's doing is it's reading the text, and then it creates the vector embeddings, and those vector embeddings need to be stored inside the system, inside this vector database, and then that will be used for the chatbot later. And you will show like where this comes in the actual RAG portion, the retrieval augmented. So what are we retrieving? Well, this is where we're going to do. And by the way, this is one of the super cool parts of this new UI is you can actually look at the data that's in there. And whenever I create these embeddings, and I'll walk through it real quick, what it's doing is it's creating a vector. So here's this massive number, but what it's doing is it's actually creating it on real content. And so it's taking the docs that are in these HTML pages, chunking it up into usable pieces, creating a vector embedding using OpenAI, putting that embedding into the database along with metadata. And it's things like, here's the file path and here's the actual content. So that whenever we're searching, we have all the base information that created this vector embedding. But the vector embedding is used in an approximate nearest neighbor search. And that's the real secret sauce to building a RAG application, is having this data available in a way that is usable by the library. So when LlamaIndex is like, hey, the user asked this question, what's close to it? This is how that gets done. All right. So when you look at this, you see that there's a ton of data in here. There's 10,088 records. How did I create that? I'm glad you asked, Yi. The first thing you have to do is you have to scrape the site. So if I run this command right here, what it'll do is it'll go through the list in the config YAML file, and what it'll do is dump the text version of the HTML into the docs directory. So if you go into the data/docs, you'll see that it has created a ton of, this is with the HTML stripped out. So for instance, like here's about SAI, zero copy of streaming index. These are all the words that were in the documentation, how to configure it. These are important. This is some of that pre-training cleanup that needs to be done. You don't want to have a bunch of useless HTML tags in your embedding data, because no one cares if there was a P tag on there. That's part of that cleanup. So what this process does is it goes out, grabs the HTML, cleans out the HTML, and cleans off the HTML and just turns it into the raw data. And that gets dumped into a directory. So after, I'll go back to my README. How's everyone doing so far? Is there any questions so far? Oh, interesting. Will the Data Explorer navigate to all PDF files? No, but you can use, there's a search mechanisms inside here where you can do some metadata filtering. There's a lot to go here. This is not meant to be a dive into this, and it's actually probably a good reason to do it, but we should create some content about just how to use this particular interface. But that's a good question. There's limited search functionality, but it is not meant to replace, say, a full library like LlamaIndex. It's just there to like explore your data and see what's in there. But that's a great question. Thanks, Wayne. So
We have
back
another
to
question from Albert saying, do we need to copy your AstraDB values or create our own tables?
create your own tables. Thank you for asking that question. Yes, you want to, and this is a good point too. This is something we talked about, is like that privacy aspect. You don't want to just throw your data into ChatGPT, for instance, and expect privacy. Especially in regulated environments, if you're in finance, healthcare, that sort of thing, you want to have your own database with your own key. Probably a good time to mention that Astra is it's got all the tickets, PCI, HIPAA, all those things that will make your life a lot easier when you're working in regulated environments. All right, let's move along. I see more questions, but we can pick those up. I just want to make sure we get to your part, Yi, and then we'll answer questions towards the end as well. These are great though. Keep them coming. We'll get to you. All right. So when I run this file, go back to this right here. When I do the compile documents, what actually, I'm going to just go ahead and run it real quick. Actually, should I run it? Probably not. When I run the compile documents, because it'll take a while. I saw a question is like, what embeddings are we using? In this case, it's the OpenAI Ada embedding. You could, and this is another topic worth diving into a lot. There are a lot of embeddings. A lot of folks are talking about E5 is the cool kid. I don't know, Yi, what's your favorite embedding, Yi? You're on mute still.
Oh, sorry. So OpenAI, I definitely start with OpenAI. And then, Cohere has put out some cool embeddings. Cohere v3. It's a little bit different because the query and the answer need to be embedded using different settings. And then there's lots of embeddings on the leaderboard. But the reason why I would suggest starting with OpenAI embeddings is because with OpenAI embeddings, like so many people are using them that your behavior is going to be relatively predictable. If you look at the Hugging Face leaderboard, there's actually lots of open source models. They're great, but you really should test them yourself on your own data, right?
Yeah.
So yeah. But open source community is fantastic, and we love them. But you should definitely test it yourself because the benchmarks are synthetic, so the performance may or may not be what you need for your application.
Yeah, and that again, this is like we're creating need for new content out of this particular workshop. I mean, just picking embeddings is somewhat it's a use case dependent, almost like a data modeling exercise in a lot of ways. And you got to think about like, what are you trying to accomplish with your embedding? Is it text? Is it images? What mode of data? Is it multimodal, etc.? So we're gonna, if you noticed, I started the embedding thing. I'm gonna kill it. But right now, what it's actually doing is going through all the text, chunking it, going to OpenAI, running up my bill right now, and it's creating the embeddings and then dropping those into Astra. So I think this takes a second, but you'll start seeing these pop up on here shortly. It'll start saying, "Oh yeah, here comes all your data." There's a bit of a lag, and like, let's see, last 5 minutes. There we go. When it shows up, we'll go back over there and check it out. But yeah, so the idea is right now is it's just creating all the embeddings. So I'm gonna go ahead and kill this right now. Control C. Okay, sorry. And I'm gonna start the UI portion of this. Now, there is a UI that is basic. The UI is using a Python script. If you don't have Intercom or Slack, I think one of the things that we were talking about is adding an actual, maybe a React or something, Next.js UI to it. Slack and Intercom were the first use cases, but this is going to grow as we go along. If you want to contribute, that's an awesome contribution, and I would love to promote it. Yeah, if you build something, I will get you in a workshop and we'll talk about it. How about that? That's you too. All right, so I'm gonna start. So what this is back end is that we'll start up, and essentially what it's doing is it's creating this the back end. Go away. I'm creating a back end that will allow a front end to interact and do this is where the RAG stuff starts to happen. So LlamaIndex is really involved in there. It's interacting with Astra on the back end, etc. Now I'm going to create another terminal here, and I'm going to try Python script. So this, you could just copy and paste this and actually put a real query in here. One of the things I don't like about Gitpod is you can't use the arrow key, but that's okay. It's like we're terminal from 1999. So what is SAI? Because that's the data that I put in there. And it should give me an answer back. And after Yi's finished, then it'll say it like a pirate, which I think is so much cooler when you're interacting with docs. It'll be like, "Arr, SAI, matey." But yeah, this is never. I mean, if I came up to you and say, "What's SAI?" and you didn't know what it was, you may hallucinate. But in this case, it actually pulled the information from the docs and did a pretty good answer, because this is right out of the about, and it gave me the exact answer. Okay, Yi, I think we need to move on to the next portion of this. Oops.
Awesome. Yeah, and just to answer a couple questions come in, can you touch on structured versus unstructured data sources? We have a whole bunch of different loaders for different types of data in LlamaIndex. That is definitely one of those things that's quite important, is how you get the data into a format that's optimal for LLMs. As Patrick has shown, he's in this example already, they have some of this processing already. And then limit on how big the knowledge base can be. There is no limit, but as you get more data, there are more advanced strategies. So that goes in quite well, I think, into this sort of like next piece of diving into LlamaIndex. So we can start the first slide. This in itself could be an hour, right? So really only going to talk about two things: production RAG and LLM quirks, right? So if you want to use LLMs and you're a developer, like I'm a developer, I'm not a data scientist, right? And this is sort of first time, really you want to be thinking about these things. Like, first off, like, how do I get this thing in production? This is why I'm so excited about what DataStax has built, is because they're using this in production, right? So you can see what the production code looks like. And it's open source. So we'll talk a little bit about some of the production RAG strategies we have in LlamaIndex. If we go to the next slide here. So
there you go.
So the example, I highly recommend you look at it. It's open source, so you can change it, right? You can customize it. And that is the number one thing when you're building a production RAG pipeline, a production RAG application, is thinking about how and tuning how the data, your data, is working with that system. So DataStax has done a lot of tuning to make sure that it works well with their system. We also have an example. This is a different type of example. It's SEC Insights. Similar idea. How can we tune it properly for this particular type of document source, which in this case is SEC filings. So if we go to the next slide, I'll show you a couple of things that we have. And one is this thing called sub-question query engine. This is in LlamaIndex. There are equivalent things in other frameworks also, but the idea is to do question decomposition. So when a question comes in, not all questions are created equal, right? When a question comes in, especially when you have large volumes of data, you need to think, what document do I actually want this question to go to? So for example, right, like if you're doing a SEC filings application like we were doing, what you don't want to do is you don't want to pull the financial data for Microsoft when they're asking about Apple, right? So If you go to SEC Insights, I don't think we're going to have time today to actually play around with it, but if you go, you'll see this sub-question decomposition in action, right? If somebody's asking you to compare two things, right, like to compare the revenue of Microsoft versus Apple, then you really want to decompose it into two questions to say, okay, is Microsoft, what's the revenue of Microsoft? What's the revenue of Apple? And then combine them together. So this decomposition and the sort of categorization of your question is very, very useful. Sub-question query engine is what we use in SEC Insights, and there's actually a whole host of strategies in this area. So this is like sort of like one production rack strategy. I'm going to go try talk about another one in the next slide. I think it's the next slide. Yes. Okay. So the other strategy that I would yes, we've had some technical
No,
issues
your slides.
So the next strategy is like small to big, right? So let's back up a second, real quick, right? So what are embeddings? Embeddings are, like Patrick was mentioning, these lists of numbers that correspond to a specific piece of text. So that sounds pretty easy, right? You just take the text, you chop it up, and then you just send it to the embeddings, and you're done. Except, okay, OpenAI's embeddings are 1,536 floating point numbers, right? There's really no way, it's really a black box. Like there's no way for me to go into the 1,536 and double check their mark, right? Like, oh yeah, this one needs to be a little higher, that one needs to be a little lower. It does not work like that, right? So what is it actually doing? What is the model actually doing? It's a black box, but if you look at the literature around natural language processing, basically you can think of a few different things it's doing. One is actually keywords. So you're like, oh, well, embedding search, it's also called semantic search. It's about semantic meaning. Yes, so semantic meaning is the second one. But why would keywords even be involved? Because if you don't have like useful keywords, if you like, especially rare keywords, then you're not going to get good search results. Like, so rare keywords is one of them. Semantic meaning, intention, like what's the intention of the text? Another one that for sure is in there in that mix is synonyms, right? So this is the place where like embedding search becomes magical. This is like why you think, okay, well, I'm not just going to use like Google search, right? Like Google search has been around for 20 years, right? I'm not going to use like BM 2.5 to just do keyword search on my data, because when embedding search is working, it's like it can find relationships between things that keyword search just can't find. Or you have to like have a huge synonym table, or you have to you have to do like a bunch of manual special casing with heuristics, all of which Google does, by the way. Google and Bing all do this, but embedding search just does that for you and in an automatic way. But now let's think about this a little bit. So you have this thing that's trying to capture the meaning, right? It's trying to capture like sort of like unique keywords. It's trying to capture the meaning. It's trying to capture like synonyms for those meanings. Then figuring out what to embed, what chunk of text to embed becomes really important. Because if your chunks of text are too big, right? They're too big, then what happens is that meaning becomes sort of diluted, right?
Mhm.
Like all your embeddings, when you actually look at the thing, they start becoming the same. Like they're all very, very similar, because you have like this big chunk of text and over the entire file. The meaning becomes very diluted. If you think about it, then the smallest chunks of text have the most concentrated meaning. However, there's a limit, right? So what is the sort of like the smallest chunk of text that has the most concentrated meaning but still has a coherent meaning, right? You don't want to get to the word, because the word itself is not a coherent intention. So you think it's a sentence, and that's true. Oh,
sorry.
no worries. It's a sentence, right? So, and that's where the smallest chunk of text is. So we're going to try that. So I wrote a couple sentences. I think it's the next slide. We'll see. I gotta.
We're gonna find out.
We're gonna find out, right? So, oh no, the next slide. Sorry. So,
Next one.
small to big, embed small, retrieve big. That's the strategy we're gonna use. And here's why. Okay, so we'll go to the next slide. Yeah, I'll show you.
So
I'll
ESRB, are you making up a new word?
I'm calling it small to big on Twitter, but I'm like maybe we should call it the ESRB strategy.
Yeah, I think everyone that's watching should chime in here. So yeah, we'll just outsource this right now. We'll go to the next slide, but if you have an idea, throw it in the chat because clearly Yi needs this workshopped.
Yes. Okay. So here's our text, right? It's fairly straightforward. Patrick McFadin is a software engineer and VP of Developer Relations. He started with DataStax in 2012. Previously, McFadin worked at Hobson's as their chief architect. Okay, very, very simple, straightforward, 3 sentences. And then we have the query, where does Patrick McFadin work? I encourage you to try this out using Astra, okay? Like, literally, Patrick is showing you have to do like all these embeddings. These are 3 embeddings, like literally 3 vectors, and then you add 1 more vector for the query. So, Patrick, take a guess. Which sentence, like if we've embedded each sentence, which sentence do you think would the embedding model say is the most nearest neighbor, the most relevant?
Probably the second one. Because
the second one, right? He started with DataStax in 2012. That makes the most sense. That's the one that we care about. I have to say, Patrick, you're wrong. Why?
I was so close.
Why?
I had a 50-50 chance.
So we'll go to the next slide. I'll show you what the right actual answer is.
All right, here we go. The right answer is
it's probably the third one. Okay, and why is that? Because McFadin is not a very common word.
No.
Right? And so the second sentence, which has the right information in it, does not have the word McFadin in it, right? So the model, even though, once again, it's a black box, it is not, it's not going to prefer that second sentence. In fact, it's going to prefer, if you go to the next slide, it's going to prefer the first and third sentences. These are the sentences that's probably going to pick out with the top K of 2. So here, this is where it becomes very important, right? So obviously, you're like, okay, well, we just embed more, right? We just embed the whole thing, right? We can embed the whole thing, but then once again, the embedding becomes diluted. So if you want the most concentrated embeddings, but you still want to get the relevant information, you have to use this embed small, retrieve big strategy. And we found in production with other people that it really does work. So we have 2 built-in modules in LlamaIndex. This is something that we are actively doing. So if we go to the next slide, you can check out. One is called.
I was going to say that's a really interesting. I never thought about like names being triggers for bad ANN searches, but that's so true.
Yeah. Because and you're like, well, why? This thing is stupider than we thought, right? But it's not, because if you think about it, like, what if it went and because he said does this blah blah blah. What if it goes and picks up another sentence from like somebody else's bio, right, that you put in your database, right? Picking out the sentences of McFadin is actually the safe, smart thing to do. But it does not give you the full context that you need. So that's where we have the node sentence window strategy. We have another one. If you go to the next slide, similar idea. It's called the auto merging retriever. And similar idea is like basically, hey, if you're retrieving a bunch of small chunks and like we see that you're retrieving all of these, then we're just going to combine it so you also get the, if you're retrieving the first, second, and fourth sentences, we're going to give you the third sentence also in the retrieval, because it's probably important, even though the embedding model doesn't think it's that close. So if we go to the next slide here. Okay, so this is the other thing that you have to be aware of. Patrick and I are old techies, so we remember Quarks mode, right? So you have Netscape Navigator here. This is IE. I think this is IE4, right?
Classic IE4.
The good old days, right? And the painful thing of having to make sure to support these browsers for years and years later. So the web development community came up with this idea of Quarks mode, right? Why? Because when these browsers came out, they were, very rough, right? Like their treatment of HTML, of JavaScript, of CSS was all very, very rough. Similarly, right now, since we are very, very early, literally very, very early, if you go to the next slide, we are in LLM Quarks mode. Like literally these things, OpenAI, Anthropic, Llama 2, like they've come out literally months ago, right? OpenAI just announced 4 Turbo, like, I don't know, like less than a month ago. Anthropic came out with Claude 2.1, I think like 2 weeks ago. Llama 2 has been around for like 4 or 5 months. They have a lot of quirks. Once again, this is a whole presentation, but I'm just going to show you a couple of quirks. Real simple. So, quirk number 1. What does decreasing temperature do in an LLM? Okay, I'm not going to, this shouldn't be too embarrassing. What does decreasing top P do in an LLM? Patrick, do you know the first one, decreasing temperature? What happens if you turn down the temperature?
You get a less, you get less spicy answers. You get more generalized answers, right?
You get less spicy answers. It becomes less random, right?
Yeah, I'm using the word spicy in a very technical way.
Yes.
Yeah.
The technical word is spicy. Decreasing top P in an LLM does the same thing. It also makes the answers less random. And if we go to the third question,
all right,
what does decreasing top K do in an LLM? I'm going to tell you, it does exactly the same thing. It makes the answers less random. So this is how we know we're in Quarks mode, right? Because you think, your software product engineer, been doing this for a while. Why do we have 3 knobs that do basically the same thing? Well, because these things were built by product engineers. They're built by mathematicians, right? So the mathematicians said, well, each of these things does a different thing mathematically, which is true. But from a developer, from a software developer who just wants to get something to work, it's kind of annoying that we have 3 knobs that do very, very similar things. So if we go to the next slide, related, right? So oftentimes when we deal with computers, right, we want the computer to return the same thing to us every time, right? This is I've been programming as a software developer for 20 years. I want to make sure everything's reproducible, right? You don't want to have like these bugs that come in like, only when the customer is, in, on vacation in Japan, or, like you want things to do the same thing every time. And with LMs, you want the same result every time. So what do? Well, if we go to the next slide, the sort of very classic thing is to set the temperature to 0, right? Because like you said, if we decrease the temperature knob, you turn it down, it becomes less random. If you turn it down all the way to 0, then that's as low as you can turn it, right?
It's pretty boring.
And
yeah.
So does that work? Well, next slide, let's see. No, it doesn't. So Amjad last year, was like, yeah, no, even at temperature 0, it does not actually give deterministic output. Okay. So this is one of the things that you have to deal with as an engineer, as an AI engineer. So next slide. But wait, there's more. Okay. So you're like, well, maybe it's okay because temp 0 does make it more deterministic. It's just not entirely deterministic, right? You might get like 4 or 5 different answers instead of a million different answers. So, but there's actually a bigger problem with temp equals 0. So if we go to the next slide, temp 0 makes the model dumber. And this is well documented, and for a long time, like even in the AI hacking community, we weren't sure why. But then I came across this paper written by this guy at Hugging Face. So the next slide. So he wrote this paper and he basically said, look, what happens when you make temp equals 0 is the search becomes a greedy search and it always picks the absolute most probable next token. But that inhibits the LLM's ability to look ahead several tokens and find the token that's like, the tokens that are like 3 tokens deep that are actually more probable than just the absolute next token.
Well,
And so, yeah.
it's interesting because this particular thing, I remember somebody giving me a really good analogy about is like early chess programs, like way back in the day, they were as good as how many moves that they tried to do ahead, right?
Absolutely.
And yeah, if you had a chess program that was on your like your old Apple II, it would do like 3 or 4 moves ahead and that's it. And it wasn't forward looking. But as computers got more powerful, it would look hundreds or thousands of moves ahead and create this prediction tree and say, oh, this is the best path based on all the different permutations. And I thought that was really interesting because it is just like that, right?
That is exactly what the LLM is doing, but um, it's also doing, because there's so many choices, right? Because unlike chess, right? Because chess, this tree is relative. I mean, it's still a very large tree. Don't get me wrong, but
Right.
it's relatively narrow. In LLM's case, at every token, there's literally tens of thousands, hundreds of thousands of choices. LLMs can perform their smartness by doing it probabilistically, right? But when you set temp to 0, you take away that probabilistic ability, and then it then just says, okay, well, I'm just going to give you the absolute most probable one. So they do a sampling. So they sample the distribution and temperature. So this is where the math comes in. Temperature technically is actually controlling the shape of that probability distribution. So yeah, so there are many quirks out there for LLMs. So where I want to leave you all at is, if we go to the next slide, is that one day there will be standards mode, right? Like I said, I believe that one day most programs, if not all programs, are going to use LLMs in some capacity. One day they will work in a very predictable way. But next slide, that's not today, right? So one of the questions, why do you want to use LlamaIndex? Next slide. You can let us deal with the quirks instead of having to deal with them yourself. So yeah, that's the end of my section. I see a couple of questions here.
Yeah, let's we're kind of at the top of the hour. Well, actually, we totally are at the top of the hour. I think now let's just jump into some questions. There's some really good ones on here. And Sameh did have a question. He has a bug report for us. Back online.
Yes.
Yes. Good job, Sameh.
Yeah. So try it out, and more importantly, look at the source code, because they did a great job.
Oh man, I gotta go
So
back and find that. What was the URL? Hang on. Talk with us. Hang on. Let me get it.
talk with us. Yeah.
Hold on.
Your
No,
next
not
job,
with,
Samay, is to build it with Astra.
yeah. Come on,
Yeah.
Sammy.
Then you'll get the monitoring that will tell you, like, hey, the queries aren't coming in. What's going on?
All right, here we are. We're doing this again. We're doing it live. Sammy. Okay, here we go. Look at this. Speeds up retrieval too. Look at that.
See? Well done.
All right.
Okay, so Ursula has a good question here. Says, how do we assess quality? Are there metrics? Patrick, I'll let you take that first, and we can talk a little bit about some things we looked at also.
Well, with ANN searches, you do get a score for the retrieval, and that's something that's really like, it's interesting because with vector search, in database world, we always talk about two things, which is latency and throughput. Those are quality metrics of your database transactions, but now it's relevance and is a third thing, and the relevance score is really critical because and what you're doing is you're saying, hey, here's a thing, find the things that are close to it. And the algorithm is able to say, an approximate nearest neighbor algorithm is able to say, here's how close it is. And so, and it'll be a 0 to 1 number. So you'll get like a 0.7. Well, that's like a 70% match, right? And it's up to you. And so Ursula, when I think of quality and what's the metrics, it's up to you, but like maybe you want the highest quality, so you want closer to like 85 to 90% or better on your retrievals, so that you just won't use an answer. Then this is where it might come in, where you say, hey, if it's less than a 90%, then just say I don't know. Like that. That just straight up say that, and that's kind of how most humans work, although not all the time.
Yeah.
Some humans make up answers. But
And then Jameson had a similar one, which is like, like if you have similar queries that are coming in that are slightly different, one of the things I absolutely encourage you to do is check to see, look at the embeddings you're getting back, right? And then if the embeddings are not similar, ask yourself why, right? Look at what's coming back from the VectorDB and look at your embeddings.
Yeah, those are really critical things. In the Q&A, there's Harpreet asked this question. I'm gonna give it to you because this is right in your thing. So it says, Yi, the example you mentioned regarding Patrick's data, since the model is searching from the corpus and it will look for the word work, so ideally it should give the second sentence, but ideally it should give the second sentence was the ideal first sentence. How do you fix that?
Yeah, small to big, absolutely, because there's or you just say, I'm just going to do bigger chunks. I think Patrick, everybody's disconnected, so I think we're
shut
we're
down.
at timing. Yeah, so
anyways, wow, it cut us off.
That went by fast, Patrick. It was fun.
It did go by fast. Yeah, we're no longer live, are we?
I guess so. Yeah.
Sorry.
Okay. So we'll say something. Yeah. Looks like our hour's up. Do you want to put your please get in touch with us? Do you want to put your LinkedIn in there?
Yeah, I will. Wow, we just got shut down, man.
The train's got to run on time.
All right. This was fun. I'm glad we did this. We opened up like 800 more doors. Yeah, is the application working? Which one? Yeah.
Okay. All right.
See you later, man. Thanks a lot.
Thanks.
All right. Bye.
All right.